All right, we're going to start tackling the separability portion of this chapter. And I believe we've already actually seen this, but we're going to introduce some language here. So an irreducible polynomial over a subfield K of C is called separable. Separable means sort of separated. So what's separated? It's separable over K if it only has simple zeros in C, or simple zeros in a splitting field. So what this means is that irreducible polynomials have distinct roots. There's no repeated roots. All the roots are distinct. If you were to label all the linear factors, they're all distinct. So that is, if we split f over C or over some splitting field, it's going to look like some leading coefficient t minus sigma 1, t minus sigma n, and each of sigma 1 through sigma n are distinct. Okay, so they're pairwise, they're different. They're all different. There's n different complex numbers there. So an example, well, it's going to turn out that C, every subfield is, every polynomial, irreducible polynomial is separable over subfields of C. So what's an example? We'll write down any irreducible polynomial. That's an example. But explicitly, we can take as an example, similar to what's in the book here, t to the fourth plus t cubed plus t squared plus t plus 1 over q. And this is irreducible because it's cyclotomic with p equals 5. Okay. All cyclotomic polynomials are irreducible, and we only really looked at them for primes, though. So this is what the fifth cyclotomic polynomial is. And the roots are the fifth roots of unity that are not 1. So either 2 pi I over 5, either the 4 pi I over 5, either the 6 pi I over 5, either the 8 pi I over 5, and these are all different. So that's an example of a separable polynomial. But again, we're going to see here in a second that all irreducible polynomials are separable, which you might say, well, Brownson, if all irreducible polynomials are separable, what is the point of this definition? Well, let me just caution you, caution, in positive characteristic, where there, you can do Galois theory too, and it's really interesting, not all irreducible polynomials are separable. So if you cared about prime fields, or not prime fields, fields of prime characteristic, not characteristic 0 like subfields of C, then you have to worry about separability. Okay, and we're going to show, and we're going to actually need it, that over C, every irreducible polynomial is automatically separable.